Okay, at this point, you should have completed a full session of extra math for some points. That was our bell ringer for today. Um, Before I move on, I just want to make sure that you know that if you want to check your answers from the homework yesterday, they are available to you. They're in that blue binder right next to my desk. That's where I'm going to keep all my keys from now on. And just flip to chapter 5, day 1, and you can see in detail the answers to yesterday's homework. Okay, so go ahead, and if you want to check your work, just go on up there and check your answers after this lesson, or we can go over it tomorrow as well. I will check in your homework tomorrow. Okay, so we are going to move on to chapter 5, day 2, exploring cubic functions again. And now we're going to get into more detail with different types of cubic functions. Yesterday we learned about cubics, what they kind of look like. So this is your basic parent function, x cubed. Okay, we're going to get into detail what happens if we change it up a little bit. As you can see here, our new function is not just simple x cubed. It's going to be this whole piece right here on your notes. Okay, so but you are going to need a graphing calculator today. Today is all about understanding how to use your graphing calculator to find a lot of the characteristics on a graph. So make sure if you have not grabbed a graphing calculator that you do so now. You can go ahead and press pause if you need to do so and then come back to it. Okay, so with that graphing calculator, we want to make sure that we can get a nice, pretty graph on paper. So there are a few things that we have to get in order for you to graph this on paper. So the things that you need are your x-intercepts, your y-intercept, your relative max, and your relative min. Okay, so cubic functions will have what's called a relative max and a relative min. They look like little maxes and they look like little mins, but they're not the highest or lowest point, so we call them relative. They're not absolutely the max in the graph, they are relative. So those are the 4 things that you absolutely need to have in order to put the graph on paper. Okay, so that's what we're going to do. So this highlighted portion, we're going to go ahead and type that in to our graphing calculator. So press y equals. It will turn red when I click it. You want to click x with that little arrow up. It's called a caret to the 3rd power. Press the right arrow to get out of that exponent. Minus 4x squared minus 11x plus 30. Okay, so again, we want to type that whole thing that we have on our notes into the y equals. Okay, now go ahead and press graph so we can kind of get an idea of what it looks like. So when you press graph, you'll notice it's not that visually appealing. So I did provide here on your notes, which will be super important that you understand what this means. Use the window -10 to 10 and -100 to 100. So go ahead and press window on your calculator. And you can kind of see those characteristics here. The -10 and 10 are good to go. Scroll down and go to your y min. Your y min, according to our notes, this is going to be our y min and our y max. We're going to type that into the window part. So -100, scroll down, and then 100. Okay. Now that you have adjusted your window, you can go ahead and press graph and now see what it looks like. And you can see here it looks way better and way easier to read than before. Okay, so we said that x-intercepts is something that we absolutely have to have in order to graph this, which it is true. So there are a couple ways to get your x-intercept. Because our scale is 1, it's easy just to read it. So -1, 2, 3 would be 1 x-intercept. So -3, sorry, my pen is delaying here. So we have -3, 0. Let's take a look at the next one. I have 1, 2. So 2, 0. And then I have 1, 2, 3, 4, 5, 5, 0. Now, another way to calculate your zeros, we can use that table that we've used last chapter. If you press second table, you can see here at negative 3, 0, I'd have an x-intercept. And if I scroll down, I would have 2, 0 as an x-intercept. And I would also have 5, 0 an x-intercept. Okay. Now we want to find our y-intercept. And when you look at your graph, you don't have to press graph. You can't really tell exactly where it's at because the scale is so big. Our scale is a negative 100 to 100. We don't know exactly what it is. So stay on that second graph, that table page, and we need to find our y-intercept. Well, that's when x is 0, which is right here. So if I scroll up, you can kind of see that our y-intercept is going to be at 0, 30. Okay. All right, so now we got 2 out of the 4 things I need to graph this correctly. So go ahead and press graph again. So now we have something called the relative max and relative min. So if you look right here, it looks like a max is right here. That's called a relative max. And right here, it looks like there's a min right here. From last chapter, we learned about maxes and we learned about mins. So we're going to use that to help us figure out what the actual points are. So whenever you're trying to find anything, you want to press second trace. So maybe make a note for yourself in these relative max and min areas that you always want to click second trace on your graphing calculator. If you use Desmos at home, you can just click the point that you need. So we're going to click second trace, the blue button, and then trace. And you want to go ahead, let's do our maximum first. And our max is number 4, so click that. And it says left bound. So all that's saying is, here's the max right here. Get this cursor to be on the left side of where you think the max is. So I'm going to move the cursor to the left side of where I think the max is. You can be like right next to it. You can be all the way to the left. It doesn't really matter as long as you're on that left side of the max of where you think it is. Press enter. Now it says right bound. Go to the right side of where you think the max is. So again, here's my max. That cursor needs to be on the right side of where you think it is. It does not matter if it's down here. As long as it's on the right side of the max, you're good. Press enter. It says, do you want me to guess it? I do want you to guess it. And there you go. So your maximum is at negative 0.999. Okay, I'm going to round that just to 1. So I have negative 1, 36. That's our relative max. So the relative max statement, the max value, the relative max of this cubic function is at 36 when x is equal to negative 1. We've done this a lot last chapter. You're using that max point to help you out here. Now let's do the same thing but for min. So second trace again. But now we want min, so click number 3. Now, here's your min right here, somewhere around the lines over here. I want to get this cursor somewhere on the left side. So I'm just going to move it a little closer just to be more accurate. The closer, the better. Okay, so a little bit to the right, the left of that min. Here's my min. That cursor's on the left side. Press enter. Now it says right bound. That means go to the right of where you think the min is. Okay, so again, here's my min. The cursor is now on the right side. Press enter. Do you want me to guess it? Yes, calculator, I do. Press enter one more time. And there you go. Your relative min is at 3.66, blah, 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 at y equals negative 14.8. So I'm just going to round it. Our relative min is going to be at 3.7, okay, because 3.66 rounded is 3.7, comma, negative 14.8. Now remember, when you're talking about the value, the relative min value, it's always the y value, so negative 14.8. And that's located at the x value of 3.7. Okay. If you'd like to leave a little note for yourself that the y value is what's going there, go ahead and do so. Okay, now that I have that, I'm going to go ahead and start graphing this thing. Okay, so those 4 points are crucial for you to get, so I'm going to go ahead and start graphing them. It looks like we have 3 x-intercepts. One is at -3, 0, so right here. 2, 0, so about right there. And 5, 0, 3, 4, 5 would be somewhere around there. Okay? Now the next part you want to graph is that y-intercept part. And that y-intercept is kind of a little high for us. So, sorry, I was trying to get that point back on there. Okay, we have to kind of adjust our scale a little bit because our graph is only telling us a 10 by 10. Well, if you look up here, it was 100 by 100, negative 100 by 100. So make your graph scale a little bit better so we can graph this thing. So let's go up by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and then 50, and then go the reverse, -5, -10, -15, -20, -25, -30, -35, -40, -45, and then -50. Okay, so that will help us graph this accurately with that high y-intercept. So I'm going to go ahead and put that y-intercept now at 0, 30. So it's going to be all the way up here. Okay, so we did the x-intercepts. Okay, we did the y-intercept. So now we're going to move on to the relative max point. So at -1, 36. So let's go ahead and graph that. -1 up 36 would be somewhere around maybe right here. Okay, and then we have the relative min, which is 3.7, so 1, 2, 3, about right here, and then down 14.8. So here's 15, so maybe around there. It doesn't have to be perfect, but somewhere around there. So now we have all 4 things that we need to graph this. And again, maybe refer back to your calculator to see kind of the shape when you draw it in. Okay, so I'm going to go ahead and graph this out. I'm going to connect the dots. Okay, so you have your relative max right up here. It comes down, gets your relative min in place, and then goes back up. And I'm just going to finish this off down here. And that kind of looks close to the graph that was on your calculator. And now we can answer all these questions. So the domain and range is going to be just like what we did yesterday. What's really nice about the domain and range of cubics is that it's all real numbers because it goes forever to the left and it goes forever to the right. Sorry, my computer's a little delayed right now. So forever to the left, forever to the right. So all real numbers is my domain like we learned yesterday. The range, it's going to go forever to the bottom and forever to the top. So again, all real numbers here. Okay, the zeros. Now the zeros, what we learned yesterday is really just the numbers and not the x-intercepts. So we're kind of just using these x-intercepts here. So I got -3, I got 2, and I got 5. Those are my 3 zeros that I have. So those are the 3 solutions. If I asked you what are the answers or the solutions to this problem, your answers would be -3, 2, and 5. Okay, almost done. The hardest part, interval of increase and decrease. And I'm going to have you guys draw in a couple of things to help us out here. I'm going to have you draw in those x values at your relative max and your min. So I'm going to have you draw a dotted line here. Your relative max is at -1, the x value of -1. Now your relative min, the x value is going to be at, let's draw in our dotted line, is going to be at 3.7. 3.7. that's going to really help you guys out with your interval of increase and decrease. I definitely recommend that you draw those in when you do it. Okay, from left to right. Remember, you're using that negative infinity. So from left to right, you can see here that this graph is going to increase. Okay, so from left to right, you want to describe the x values of where the graph is increasing. So from negative infinity, and it stops increasing at the x value of -1. That's why I like drawing in those dotted lines, because it helps me stop. It knows where to stop increasing at the x value. So negative infinity to -1. Okay. Now, if you look here, the next part's going to decrease. So I'm going to move down to that decreasing part and describe that. Well, where I stop is where I now start. So -1. And I'm going to go all the way to 3.7. So my graph is decreasing on the x values -1 to 3.7. Okay, so I'm going to go ahead and put that in. So I'm decreasing from -1 to a positive 3.7. Okay, then my last part, you can see here, I'm going to increase again. So I'm going to have 2 points of increasing on this graph. Where I stop is now where I'm going to start. So I stopped at 3.7, and I'm going to start there now and go on forever to the right to positive infinity. Okay, so I'm going to increase from 3.7 to positive infinity. And we're going to use a little u in between. That just means and. You don't have to if you don't want to, but that's just the mathematical way to put it. So I'm going to explain that one more time. You can see here from left to right, my graph is going to increase, and then it's going to start to decrease, so decrease, and then it's going to increase on this last part. So there were two pieces that increased on the graph, and there was one piece that decreased. Okay, that's always going to happen with cubics. It's going to happen a lot. Okay, again, only the x values are used for interval of increase and decrease. So x values only. Okay, and that is how you do that type of problem. It's a lot of work. Okay, but once you get the swing of it, it will get better. And what's nice is that last chapter we did practice a lot of these concepts, but now we're applying it to a new graph, which is the cubic graph. Okay. All right. So let's talk about what it really means to be a function. So f of x is going to refer to the function value, which is your y. So whenever you say the function value, that's really your y values. And it's going to happen at a certain x value. Okay, so again, f of x refers to the function value y at a certain x value. Does a function have an absolute max or min? Why or why not? We kind of talked about this a little bit already. So a cubic function, which is what we just did and what we did yesterday, that kind of looks like this. That's what a cubic function is. Again, a cubic function is something like x to the third power. Okay, it will not have an absolute max or min. So no, because it has a range of all real numbers. Okay, so it will never have something that's the highest point, which is the max, or a lowest point, which is an absolute min. Okay, we do have these relative max. This guy is a relative max, and this guy is a relative min. Okay, what is an absolute max or min? Let's go back to the first day when we did quadratics. This guy, this would be an absolute min. There's no point that's lower than 0. There's nothing down here. Okay, that's what it means to be an absolute min. Okay, again, a relative max and min means it looks like a max, it looks like a min, but it's not necessarily the highest or the lowest point you see on the actual graph itself. Okay, so it is a high point, it is a low point, but it's not the highest. It's not the absolute max. It's not the absolute min. Okay, so again, it would not, because it has a range of all real numbers. It's not going to happen. Okay, so let's do another example, and then I'll let you guys get going on your homework. Okay, so let's do another one. Let's get out our calculator. All right, so go to y equals, clear it out, and we are going to go ahead and we're going to graph this new one on the second page, this guy. All right, so let's go ahead and graph it. So 2x to the power of 3, or 2x cubed. Go to the right. Let me clear this out so that you can see it more. So 2x to the power of 3 minus 6x squared minus 26x plus 30. All right, so we have this. Remember that there were 4 things that we do need to have on our graph in order to graph it on paper, and that was the x-intercepts, the y-intercept, the relative max, and the relative min. Okay, so let's go ahead and figure those out. So we're going to go ahead and press graph. What's nice is that if you can see here, our window is still negative 100 to 100, so we don't have to change it from the last problem. Again, what you would do is you'd press window in order to change that, but again, you can see here negative 100 and 100 are already on it. Okay, so we have our graph. There it is. Let's go ahead and find our x-intercepts. Okay, our x-intercept looks like we're at negative 1, 2, 3. So we have negative 3, 0. We have positive 1, 0. And we have positive 1, 2, 3, 4, 5, 0. So you can see that by just looking at the graph itself, or you can press second graph, which is the table, and you'll see here at negative 3 you have 1 at 1, 0, and you have 1 at 5, 0 there. Okay. Now that we got this table, so again, press second, the blue button, graph, and that gets you your table. We can now find that y-intercept. So again, we're looking for when x is 0. So that's going to be 0, 30 again. Now again, what you look for on your calculator is when x is 0. That's what you're looking for. Okay. Now we have to find our relative max and min. So go ahead and press graph again. Okay, so when we press graph, we can see that the whole picture here, we're going to find our relative max. Now remember, you have to press second, the blue button, then trace, and that's going to allow us to find our relative max value. So we're going to press 4 for max. Now remember, it asked you for the left bound. So here's our max. I want to move this cursor to the left of where I think the relative max is at. So I'm going to press left, 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 until I get really close to that max on the left side. You can see the cursor is on the left side of where that relative max is. Press enter. Now it asks you for the right bound. So go right, 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 until you go right of where you think the max is at. Again, it doesn't be perfect. It says, do you want me to guess? I do want you to guess, calculator. So let's see what it gives us. It says we have a relative max at negative 1.3, comma 49.3 technically if you round it, or 49.2. It really doesn't matter. I'll round it just to be safe. Okay, so 49.3. You could have just kept it 49.2. It really doesn't matter as long as you're really, really close. Okay, remember what we're asking for is the value, the closest high value for that relative max, and that value is 49.3, and that's always going to be at that y value at negative 1.3. Now let's go ahead and find our min. Again, press second, the blue button, trace, and click option 3 for your minimum. Now, again, it wants you to go to the left of where you think the min is. So here's the min. There's where my cursor is at right now. Okay, so I'm going to go to the left of where it's at. So I have to press right just to get over there. So I'm going to press right until I get close to that area. So I'm kind of close. You can choose there. I'll go a little bit closer maybe. Press enter. Now it says the right of where you think it is. So again, here's my min. I'm going to go and move that cursor to the right side. Again, it does not have to be perfect. Press enter. And then you got to press enter just one more time. And there's our min. So about 3.3 comma negative 49.3. Okay, again, you could have used negative 49.2, not the end of the world if you did not round it. Okay, so again, where is a min value? So on your graph, where is there a possible relative min? Well, that value is going to be at negative 49.3 when x is 3.3. So you're using this here to help you out, and this is where that y is. Okay, so I know my shape of my graph is going to look like this, so let's go ahead and start graphing it on paper and answer the rest of the questions. So just like last time, we needed, because our range was so high from negative 100 to 100, we do have to label those axes again. So 5, 10, 15, 20, 25, 30, 35, 40, 45. Again, just to get yourself a more accurate graph. Okay, do it again. Negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40, negative 45. Okay, so again, I just went up by 5 so that I can get a better graph here. And now let's go ahead and start putting those 4 things that we found on paper. So I have negative 3, 0, so 1, 2, 3. Here's negative 3, 0. Then I have 1, 0, which is about right there. And I have 5, 0, so 1, 2, 3, 4, 5. Okay, now our y-intercept is next. We already did our x-intercepts. Now let's move on to our y-intercept. So 0, 30. So left to right 0, up 30 is about right there. Again, now y-intercept's done. We graph that guy. And now let's graph our relative max. So negative 1.3, so maybe somewhere around there. And then up 49.3. So I'm going to come all the way up to 49, which is probably like all the way up here somewhere. And then now we're going to go get our relative min on the graph. So 3.3, so 1, 2, 3.3, down 49.3. So I'm going to go 1, 2, 3, down all the way, maybe somewhere around here. Again, does not have to be perfect. Now remember, when you look back at your graph, this is what it's going to look like. So let's go ahead and connect the dots from left to right. Okay, so from left to right, it looks like we're going to be connecting those dots. So from left to right, this point, here's our max. And then we come down, hit our y-intercept, go through our x-intercept, go ahead all the way down here and hit that minimum. Come back. Remember, just connecting the dots and then draw your arrow. This guy is an extend down. Now, again, you could draw all the way from down here and go on. That's fine, but it's easier when I just graph it from point to point. Like all cubic functions, our domain and range is all real numbers because I go forever left, forever right, forever up, and forever down. Your zeros are always those x values, so negative 3, 1, and 5. So those are our 3 zeros. Remember, those are the solutions to your problem. If I asked you what are the solutions, what are the zeros, it would just be those 3 numbers. Okay, last part, interval of increase and decrease. So put in your negative infinity because you're going to go forever left and forever right because we're only using x values here. Now, again, what I like to do is draw in this dotted line because I know it's going to be like a barrier for interval of increase and decrease. So my relative max had an x value of negative 1.3. So I'm just going to go ahead and write that in for myself. So negative 1.3 is where the x value is of my relative max. And I'm going to go ahead and draw in my 3.3 here, somewhere around there. So 3.3, that's going to help me with my interval of increase and decrease. So now, interval of increase. From left to right, I'm going to be increasing first. If you watch, I'm going to increase, 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 increase from left to right. But we have to talk about where is it increasing, not what the part of the y values. We're looking at the x values. So from negative infinity, it's all the way over here to the left. We stop at this little wall, this negative 1.3. That's going to be our interval of increase. So from negative infinity to negative 1.3, it's always your x values. Okay, so again, I was increasing here. I'm increasing. Then if you look, I start to decrease. That's green right there. So I'm going to decrease right here. And that's going to happen from where I left off at negative 1.3. And it's going to stop decreasing at the x value of 3.3. So I have negative 1.3 to positive 3.3. If you look here, there's only one interval of decrease. That's it. Just this guy in green. That's decreasing. Okay. One last piece. We always start at negative infinity and we end at positive infinity. Wherever I stopped at 3.3 is where I'm going to start. And I stop here on the right side at positive infinity. So I have my little u representing and 3.3 to positive infinity. Now again, where you stop is where you start. So you can kind of see here. I started at negative infinity, stopped at negative 1.3, and then I went to 1.3 to 3.3. And where I stopped at 3.3, I started my next interval at 3.3, and I went on forever to infinity. Okay, so it represents all the values on the possible graph here, all the x values. Okay, so again, you kind of watch. I increase, then decrease, then increase. Okay, increase, decrease, increase. So this guy was increasing over here. Okay, the next part. Write a cubic functions with zeros of negative 4, 2, and 3. Write it in standard form. I'm not going to have you guys write it in standard form. I want you just to focus on these graphs. Okay, so standard form would be what we did yesterday. So this up here, if I go back, this guy would be standard form. Okay, this would be intercept form that we learned yesterday. So intercept form versus standard form. Okay, so we're not going to do that. We're just going to write it in intercept form. Now remember, count the zeros. It's a cubic function, so I should have, oh, something happened. I apologize. Okay, it is a cubic function, so it should be x to the third power. Okay, or you should have 3 x's represented. Now, when you're writing it in intercept form, you always want to write it as x minus the 0, x minus the next 0, and x minus the last 0. So again, all you're going to do now is you're going to plug these numbers into the problem. When you plug in negative 4 into a negative, it changes to a positive 4. Plug this guy in, nice and easy, it's 2. Plug this guy in, it's nice and easy, and it's 3. Okay, so this would be my final answer. If you want to make it look more fancy in function notation, put that f of x in the beginning. That is a cubic function with 3 x's, cubic 1, 2, 3. Okay, so that satisfies the x cubed part. And the zeros are negative 4, 2, and 3. And you could check that. Remember how you guys were really good at this yesterday when you solved for it. If you were to solve for this, you would get back negative 4. If you were to solve for this, you would get back 2. If you were to solve for this, you would get back 3. So you did it right. You can make sure that you did it right by checking it. Okay? All right, so the rest of the time is yours. You can use it to work on your homework. Please don't abuse that time. Make sure you take advantage of it, especially because you have the graphing calculator. And go ahead and at least get the graphs on paper. So before you leave today, there's only 2 questions for homework. I would recommend that you put both of those into the calculator. Get your 4 things that you need, your x-intercept, your y-intercept, your relative max and min, and then you can answer the questions later for homework if you need to. If you're at home and you don't know how to get these graphs without a graphing calculator, on Google Classroom, if you look, I put Desmos on here. You have a Desmos graphing calculator. If you go in and click that, all you have to do is type in that function into Desmos, and all you got to do is click the point you want. So like, let's put in the one that we just did. So in Desmos, if you put in like x plus 4, x minus 2, x minus 1, you can click the points you want. So if you want a relative min, click it. There it is. Boom. That easy. Okay, so it is easier on Desmos, but you can't use Desmos on the SAT or in this class for the test. So make sure that you're able to use the calculator. But if you are at home, make sure that you use Desmos, okay? All right, I hope you all have a great day, and I will see you tomorrow.